Alright, these are some lab helps for the enthalpy of chemical reaction lab. We talked about the pre-lab a little bit today in lab, but if you missed any of the reactions, I put in the reactants. Remember that if it's aqueous and it contains an alkali metal, it's soluble. If it has chloride and it's not paired with silver, lead, or mercury, it's soluble, and that strong acids would be soluble as well, such as hydrochloric acid. Um, you're going to use the chart with the delta H's, the delta G's, and delta S's to calculate the enthalpies of the reactions. You need to make sure you include that table in your lab report. Before I move on to the data, I just want to point out that I kind of summarized what y'all did. You did 3 reactions, one with the strong acid and strong base, sodium hydroxide, hydrochloric acid, one with a strong base and a salt, sodium hydroxide and ammonium chloride, and then finally the third one between hydrochloric acid and ammonia. All of the solutions were 2 molar, and they all contained 50 mils of each solution, so you had a total volume of 100 mils for your 3 reactions. You should have had an initial and a maximum temperature recorded for each of your 3 reactions, and from that you should have been able to calculate a temperature change. Your temperature changes should be recorded to 1 decimal place. So in terms of questions, I helped some of you with this earlier, but just so we're all on the same page. You want to make sure you show me a sample calculation for 1 and 2. There's only one calculation you have to do for 3. For 4 you'll do 2, but they're totally different, so you need to show me both. And then just make sure you use your sig, fig, and rounding rules. For number 1, it says you're going to calculate the amount of heat energy produced in each reaction. You can do that by finding the energy of the solution. You will need the mass, the specific heat, and your temperature change, because we were working with coffee cup calorimeters. You did not weigh your solutions. You did measure their volumes. You used 50 mils of each solution, which gave you a total volume of 100 mils. And you're allowed to assume the volume's added completely, so 50 plus 50 gives you 100. And I also gave you in question 1 the density of the solutions. So between the volume and the density, you should be able to find the mass of your solutions. You have the specific heat that was given to you in question 1, and then you have the temperature change, which is what you measured. Once you've calculated the Q of solution for each of your 3 reactions, you would take the opposite of that Q value to get the Q of the reaction. And that's what you're looking for in question 1. Question 2 wants you to take the Q of your reactions from question 1 and determine what the enthalpy values would be no matter how much of the reactants you combined, aka the delta H for kilojoules per mole of reaction. Number 1, I believe you're going to solve for mostly in joules, so make sure you convert from joules to kilojoules. And then just remember from what we talked about in class that to find the enthalpy of a reaction, you take the energy released by that reaction or absorbed, the Q value, and divide it by the moles of your limiting reactant. Again, if we go back to the 3 reactions, you'll see that you have the same concentration of each reactant, and you use the same volume of each reactant. And I believe when you wrote your equations, you noticed that everything was in a 1-to-1 ratio. So both reactants are used completely. So you can use either reactant's moles as your limiting reactant, but you would need to determine the moles of that reactant by taking the molarity times the volume in liters. Once you've determined the moles, you would take your Q of reaction from question 1 for each of the 3 reactions divided by the moles. And that would give you your 3 enthalpy values for your reactions. 3 and 4 are going to be using Hess's law. You're going to use your enthalpy values for the first 2 reactions, and you're going to see, is there a way you can combine those first 2 reactions? So we're going to take the reaction between the NaOH and HCl and the reaction between the NaOH and NH4Cl, and we're going to see if we can make the reaction between HCl and NH3. So you're going to go back to those reactions that you wrote right above that for 1, 2, and 3 and try to determine, is there a way I can combine these 2 to give me my third one? Once you do that and you apply Hess's law, you're going to determine what the molar enthalpy would be if you just based it on those first 2 reactions. I believe in part the reason they're having you do this, the third reaction, you did not get as much of a temperature change as I would have expected. I don't think that one does as good of a job with the coffee cup calorimetry. So that's why we're just going to use the first two to see what we can get for the third one. You're going to repeat that for the data that you collected for your pre-lab. It says use Hess's law in question 4 and the accepted values of delta H in the pre-lab section to calculate delta H for your reaction 3. So using the chart that you calculated the delta H values for the 3 pre-lab questions, you're going to combine the first two, just like you did for the previous question, and combine the delta H's together to see what the accepted enthalpy value would be for reaction 3. And then the second part of question 4 is to calculate percent error. Question 3 gives you the experimental value. Question 4 gives you the accepted value. And so we want to see how close the results were to that accepted value using your percent error calculations. So finally, the last question, you actually did measure the third one, and you did calculations with the third one to determine the energy released by that third reaction as well as the enthalpy change of that reaction. So it says this is experimental process support Hess's law. You obviously have your percent error calculation to look at in number 4, but you could have also calculated the percent error between what you got for the third reaction experimentally and what you got using the theoretical data. So you could talk about that as well. Your results from number 4, as well as just how the data compared for the reaction 3. Did it support it, yes or no? And then what were things we could have done to help improve our results? Are there other ways to make sure that the energy is conserved? What are things you could have done experimentally to perhaps collect better data or more accurate data? Think about things like that. So hopefully that helps with this lab.